For more videos, visit forthesakeofeducation.com. Alright guys, now we're going to do these two problems at the same time. That says express each vector in Cartesian vector form and then determine the magnitude and coordinate direction angles of the resultant force. Sketch this vector in the coordinate system. Alright, so we got F1. Now F1 has an X component, a Y component, and a C component. You can see that the Y component of F1 is 0. It doesn't have no value on the Y direction. Now the X component is going to be 90 times 4 over 5, which is equal to 72. The 4 over 5 came out of this triangle. And the C component is going to be 90 times 3 over 5, which is going to be equal to 54, which came out of this triangle right here. So the value will be 72i plus 0j plus 54k. Now we got F1. F2 is the tricky one, not really. F2 has an X component, a Y component, and a C component. Now the first thing we're going to find is this vector right here. It's a projection of F2 into the X and Y plane. We're going to label it like this. This is this projection, this one right here. And to find that, you do F2 cosine of 60, since we're given the angle right here. And when you calculate the projection, it's going to be 75. Now that you have this projection, you can find the X and Y components. The X is going to be the projection times the sine of 45, because we're given this angle right here. And the Y is going to be the projection of the cosine of 45. In other words, this is the Y component and this is the X component. So this is clearly the cosine of 45 times the projection, and this is clearly the sine of 45 times the projection, which sine of 45 and cosine of 45 are the exact same thing, so they're both 53.03. And f of c is simply f of 2 sine of 60, because it's this vector right here, which comes out to be 129.9. So this vector is 53.03 I plus 53.03 j plus 129.9 k. Now that's two vectors. Hold on, let me start. That's one vector. That's f of 2. And f of 3 is the easiest one, because the X and Y component are 0. So it's 0i plus 0j, and it goes straight up on the C axis, so it's plus 200k. So this is it for the first part, which is expressing all three in Cartesian vector form. Now we gotta find the resultant force, and to do that we gotta add the x's together, the y's together, and the c's together. And when you do, you're gonna get that the value is 125.03 I plus 53.03 j plus 382.9k. And this is the Cartesian representation of the resultant force. But we need to find the magnitude in order to find the direction angles. The magnitude can be calculated by doing the square of each value, add them together, and square root them. So this is the x, this is the y component, and this is the c component. You plug them into this formula, and when you do, you're gonna get that the resultant force has a magnitude of 406.3. Now to find the direction angles of the resultant force, which are these three. Remember, this is for the x, this is for the y, and this is for the c. All you gotta do is the cosine inverse of the x component over the magnitude, cosine inverse of the y component over the magnitude, and cosine inverse of the c component over the magnitude. And when you do, you're going to get that the angles are 72.1 degrees, 82.5 degrees, and 19.54 degrees. So final answer, final answer, final answer. This is the magnitude, and these three are the Cartesian representations of the vector. Now, it's kind of complicated to sketch it on this small little drawing, but let me attempt. So this is going to be around 125 on the x, so let's say somewhere right here. 53 on the y, and 382 on the c, gonna be somewhere right here. More or less. Final answer.